Hi and welcome to this Arduino tutorial. In this video I'll show you how to easily connect your ESP8266 Wi-Fi module to your Arduino UNO. So first of all you want to get out your breadboard and of course your ESP8266 chip. Now I had some trouble actually fitting it to the breadboard because the gap between the pins of the ESP is very narrow. So what I've done is just soldered them onto a piece of PCB board and just soldered two sets of pins, just extending the gap between them, making it fit perfectly on the breadboard. Underneath the chip there are a diagram showing you what function each pin has. So I'll put up a diagram showing it to you. Now the pins are as follows. We have the 3.3 volt connecting the power to the chip. You want this to be connected via a power regulator, as the 3.3 volt pin on the Arduino cannot supply enough current for the chip to function normally. Then we also have the reset pin, the enable pin. You want this to be set to high. The TX and RX pin, two I/O ports, and the ground pin. Now you want to fit the ESP onto the breadboard. Go, and we'll start connecting it to the Arduino. So we'll start by connecting the ground. See, they're a bit awkwardly placed underneath the chip, but we'll go on and connect it to one of the rails, and then connect it further to the Arduino's ground. There we go. Then we'll go forth and connect the VCC, the 3.3 volts. Now you want to make sure that you connect it to a 3.3 power regulator, but for the demonstration of this video I'm just going to connect it to the 3.3 volt. We're just going to show that it's functioning properly. So we'll connect one of the ends to 3.3 volts and then to one of the power rails, because now you want to not only supply voltage to the 3.3 volt, which is the right uppermost pin. See, there you go. You also want to connect it to the enable pin, which is located not below the 3.3 volts but below that again. So you just want to connect it there. Now between these two are the reset pin marked RST. You want to let that be unwired. Now since we just want to test if the ESP is functioning properly inside the 0 window, you want to connect the ESP's RX pin, which is the left uppermost pin, to the RX pin of the Arduino. So RX to RX. It's a little bit awkwardly placed, so we're just going to add a little wire underneath here. And let's wire it over here. Then remember RX to RX, so pin 0 on the Arduino, at least on the UNO. And then we are also going to connect the TX pin, which is the right lowermost pin, to the TX. So TX to TX, or pin 1 on the Arduino UNO. There we go. Now that you have connected to the Arduino, we're going to supply some power. I'm using the USB cable here. Now if you don't see an immediate blink like I just did, you may want to just disconnect and reconnect the power supply. Like that. Now it's important to remember that if you're using a power supply, which you should always connect its ground to the Arduino's ground and the ESP's ground, as they all have to have a common ground to function properly. Also, you do not want to connect the power output of your power supply to the power supply of the Arduino. So if you're going to use a power supply, you want to connect this end to the supply, to a power supply, but not to the Arduino. So let's go and fire up the Arduino IDE and let's test it. Now the first thing you want to do after starting up your Arduino IDE is to make sure that you have a clean and fresh program with just the loop and setup function. To achieve this, you can go to File, Examples, Basics, and open up the bare minimum program. Then you want to upload this to your board. Make sure that you have selected the correct Arduino board and COM port. Then you want to upload it. Now after it's finished compiling and uploading, open up the serial monitor and make sure that you have both NL and CR selected. Then you'll type AT and hopefully it should return OK. Now if it doesn't return OK and you have selected both NL and CR, it's most likely due to an incorrect baud rate. If you have a new ESP, it's most likely going to be 115,200 baud. So you'll select that and type AT command. That should hopefully return OK. Now to convert the 115,200 baud rate to 9,600 baud, you'd select the correct baud rate. For me that is 9,600, and then you want to type AT plus CIO baud equals 9,600 and then enter. When you have the correct baud rate selected, remember to change it from 115,200 baud or whatever baud rate you had previously to 9,600. Now to connect it to our Wi-Fi network, you have to set it to client mode. To do this, you'll type AT plus CW mode equals 1. 1 is for client mode, which will let it connect to a Wi-Fi network. 2 would be an AP, then it will act as access point itself, and it also has a dual mode, so then it can act as both an access point and a client. But we're just going to use client mode. Hit enter, it should return OK. Now to list all the nearby access point, you type AT plus CW LAP. Hit enter. Then you'll get nearby Wi-Fi networks. So I have a Wi-Fi setup called some Wi-Fi. Now to connect to that network, I'll type AT plus CW GAP equals quotation marks, the name of the network, and it's case sensitive, so I'll type some Wi-Fi, quotation marks at the end, comma, quotation marks, no space between, then the password of the Wi-Fi, which means Wi-Fi test, and then quotation marks again, password is also case sensitive, then enter. Then after some time, yeah, it should return Wi-Fi connected, Wi-Fi.IP, OK. Now to get info about your network, you can type AT plus CIFSR. Oops, don't forget that command is also case sensitive, so AT plus CIFSR in all caps, enter. Then it will return your IP. So for me it's 192.168.43.153. Now that's how you connect the ESP to your Arduino and also test it, see if it functions properly. Now in the next video I'll use the blynk services, which let us connect the Arduino to the internet and lets us control the Arduino via our smartphone. So if you liked the video, I would appreciate a like, and also you can subscribe to get my next videos.